Today we have a problem from the HMMT of 2005. It states that the number 27,000,001 has exactly 4 prime factors. We need to find their sum. The point of this problem, or what they really want to know, is your skill of factoring. We need to break this up into 4 prime numbers. We can do it very simply. So 27,000,001, this is just equal to 27,000,000 plus 1. And then we can still factor this by using scientific notation. This is equal to 27 times 10 to the 6th power plus 1. And it is here where we first use substitution. I'll use a comma. We let x be equal to 10 so that we can write it in terms of x. So this is now 27x to the power of 6 plus 1. We can further rewrite this. This is equal to 3 cubed times x to the power of 6 plus 1. And now we can factor this out. So this is just 3x squared to the power of 3 plus 1. Well, now we can actually make this an formula from algebraic terms. 1 is equal to 1 cubed, since 1 cubed is still 1. According to the formula, we can factor this out as 3x squared plus 1 times 3x squared minus 3x squared plus 1. Oh, sorry, I need to use the brackets, but yeah, anyway, you get the idea. So, this step is optional, but we use substitution again to make this easier to read, and we substitute the x squared. So we let a variable, say a, be equal to x squared. So now this is going to be 3a plus 1 times 3a squared minus 3a plus 1. I need to use brackets again. So yeah, we need to take this term here, and transform it into a 3a plus 1 squared. So let's just do that. So this is equal to 3a plus 1 times, well, this is 3a squared. Well, we can make this a square, so we multiply it out. The equation is plus 6a plus 1. Still need to get that minus 3a, so subtract 9a. Now we can make this a formula. This is equal to 3a plus 1 times, now we have the 3a plus 1 squared, so 3a plus 1 squared. We can also factor out this 9a to be 3 squared times a. So now we can just substitute the x back in and the a back in to solve for the 4 prime factors and add them. The first thing we're going to replace is the a's. So in this equation we have right now, this is all in a terms. We convert that to x squared terms, and then convert it to 10 terms and solve for our 4 prime numbers. But we convert it to x squared first. The first number is 3x squared plus 1 times, this is now 3x squared plus 1 squared minus 3 squared times x squared. We see that in these brackets, this is a formula, the a plus b times a minus b formula. So we can actually rewrite this. So let's do that. So it's going to be 3x squared plus 1 times, what's now inside is 3x squared plus 1 plus 3x times 3x squared plus 1 minus 3x. And we have to make this equal to something. Well, we actually know what it is equal to. We got all of this from the number 27,000,001. So this is really equal to 27,000,001. And it is still equal to 27,000,001 because every step that we did didn't change anything to the overall value of this. Now we have it in x squared terms. We let that x be equal to 10, so we can find three numbers from this. The first number, 3x squared, x is 10, x squared is 100, 3 times 100 is 1301. I'm sure you know how to solve this by now. You just multiply and add. Because now our second number is going to be 331, pretty simple. The third number, 271. Basic addition and subtraction. This is now equal to 27,000,001. There. But we have three numbers here, not four. They want four prime factors. So one of these numbers is an imposter. So one of these numbers is not prime. And after some searching, we see that 301 is not prime because it can be factored into 7 times 43. So now we have our real four numbers. 7 times 43 times 331 times 271 is equal to 27,000,001. So now we can add all these four numbers. So it's going to be 7 plus 43 plus 331 plus 271 is 50 plus 602. So our answer, or the sum of all the four prime factors of 27,000,001 is 652. So that is indeed our answer.